Thank you very much. Hello, everyone. Is my mic on? Yeah, cool. You can hear me. My name is Leah, and I work as a staff engineer at FundApps. For over a decade now, I have been solving client problems and business problems using .NET, where technology is the right thing to solve problem with. And for the last 5 years of that, using AWS as well. Today, I'm going to share with you the real story, the challenge we in FundApps face as a startup that started signing more and more clients and larger names, how we re-architected our platform to be able to support that growth, and how we made it cheaper, faster, and greener. This was us. London, our office, 4 years ago. It's Monday morning, stand-up has just finished. I have coffee in my hand and I'm about to start coding until pager duty alarm, pager duty alarm. Slack is overflooded with errors and that all too familiar deja vu. Did we put one too many client on a single long-lived Windows box? Or did the weekend database backup run into Monday and now they're colliding with client peak times and the database is on fire? Or is that one client that we signed last week a little bit too big for the Windows box 02A that we put it on, and now this is just going crazy? Our platform was unsustainable. The single process application running on a long-lived, self-hosted Windows boxes was not able to scale. The only thing that we could do at this point in time is to throw more money at it, to give it more memory, to give it more CPU. Our cost of maintenance was growing rapidly with every single client we signed and was higher than any business would want. And we were afraid to sign more clients, especially bigger whales. At FundApps, we provide compliance as a service to the investment management industry, a service that allows our clients to outsource the process of knowing when they need to disclose to the regulators. Our clients are banks, hedge funds, pension funds, different asset managers. We monitor over 17% of global assets under management for shareholding disclosure for our 160 clients on a daily basis. This is over $20 trillion US. The importance of doing these calculations correctly and on time to provide these results to our clients to be able to action on them is really high. And if we didn't, it could seriously damage their reputation, make a dent in their bank account, and in some countries, they could even end up in jail. We were founded in 2010, which means we have been around for a while. And what's really interesting for today's story is that we have been bootstrapped. This means we didn't have any injections of money to rebuild things from the ground up, which means we have also been very lean and tactical, especially in the early years of growth. Our clients will on a daily basis provide us with a set of their end-of-day positions, tens of millions of them. At the heart of what we do is highly complex and bespoke rule engine, and we use it to model the regulation. This rule engine will take clients' positions, it will enrich them, it will run regulatory rules over them, and it will run over 20 million of calculation over millions of positions. And then we will generate the results that clients take to go on with their daily workflows. This batch process, the rule engine, is a critical step in our clients' daily workflows. When FundApps was founded, we built the rule engine with technology available in 2010. This means we built the monolith. We had a small farm of relatively large Windows boxes that were doing the work, running the rule engine. Our storage was SQL Server, and yet again, self-hosted on another set of relatively large Windows boxes. When the markets are open, our clients would send us their positions every day, usually just once a day though. This means that these large Windows boxes were mostly just sitting around and idling, not doing anything. They were really underutilized, even if we shared them between multiple clients, which we did. And in order to support those bursts of compute for our clients when they send the position files, without impacting their runtimes, these boxes need to be always on and over-provisioned, which means they were also costing us a lot of money. Sharing these boxes cut the costs, but it led to noisy neighboring issues. Our clients' runtimes were affected, they were unpredictable, and we had file failures. And even with over-provisioned instances, we were still facing computational bottlenecks when our more complex clients were running the files. To be completely honest, we lost the client because we couldn't support their workload. Even after using the biggest AWS box at the time of 1 terabyte, their runtime was still taking 16 hours. I think I went through all of these. Storage was another problem. Rule Engine was generating a lot of data, over 300 gigabytes a day, and that was in total around 400 terabytes, which means we also had backup issues. And on top of that, this self-hosted, long-lived infrastructure came with all of those challenges of maintenance work that happened over the weekend, patching, drifting configuration. With these challenges and this infrastructure, it would be very expensive to support any larger and more complex clients. And we were worried that we're not able to support them, which would be commercially dangerous. This means that this batch process, the Rule Engine, became a serious business and sales barrier. So we decided to make a change to rebuild the engine from the ground up. In order to support our clients longer term, we need to make this massive investment both in terms of money and time. This is what we came up with, cloud native and share nothing. We were already big on AWS, so we decided to use as many managed services as we can. That means we can focus on our business challenges, our client challenges, instead of the technical ones. Cloud providers are amazing at this. They can do all of that undifferentiated work of scaling the servers, patching the boxes, backing up the databases. They can do the heavy lifting for us. We wanted to enable the work at extreme scale, improve our security, increase our visibility, and also simplify our operations. And we have, by designing our system to be able to horizontally scale computation, and by not sharing the infrastructure between different clients and different components where that made sense. Additionally, we decided to use different storage solutions, the storage solutions that fit the data better, that fit the problem that we're trying to solve better. By that point, we only had one monolithic database, the SQL Server. Today, I'm going to show you 3 patterns that got us to feel those benefits that are using these design principles. Every one of these patterns got us closer to migrating all of the clients to the new infrastructure. Clients of different sizes and different shapes, with all of the features that existing platforms supported. As one of my colleagues said, it was like changing tires on a racing car while the car is still moving. It was super challenging, but it was also really, really fun. So we chose AWS, and these patterns are composed of components, and I will use AWS components, but majority of these components can also be found in other big cloud providers. So just keep that in mind. Let us introduce first main pattern, the distribution of compute. The Rule Engine uses step functions to orchestrate the work. The first step of the step function, of the flow, is to partition the work. That those instructions are then stored in S3, and they're used in the next step. To every one of those instructions is then sent as a single SQS message. To track the work, we also store it in Dynamo. So step functions are there looping in the background and checking the Dynamo table to see when the work is done. While that's happening, something needs to process these messages. And this is our fleet of Fargate containers that we spin up when an engine starts to run. And this fleet of Fargate containers is going to take a message by message and do the work, do the calculations for us. I call them mini rule engines. Each one of our clients will have 50 to 300 of these containers. And it will depend on the size of a container, the size of the client, how many of them they will have. With 200 client environments, with each one of these sets of containers being in their own AWS account and removing the noisy neighboring, this means we could be running 80,000 Fargate containers comfortably at a single point in time. And we are using only a fraction of AWS's limit. We could be using 2,000 or 3,000 containers if that made business sense. So with this pattern, we remove the bottlenecks on computation on a CPU and memory, especially when large clients are running the files. We also remove the noisy neighboring, as this is isolated in AWS accounts. And as we are spinning up these Fargate containers every time client sends a file, we are not having that underutilized compute just sitting there and idling. So we are also saving on energy and the cost. We solved the computational problem, same diagram. So we solved the computational problem and we still have storage problems. So two problems. Again, bottlenecks on the CPU when these bursts of write are happening, potentially from multiple clients at the same time, shared database. And then another one, which is the rising amount of this data being stored in a database, which means we also have database backup issues. So now we're digging into what are actually the types of data that we are storing in this database. And actually, it's not the results of the computation, it's the positions of clients that we enrich and that we store, that we need to do the calculations, but also to provide it to the clients to reference later on. And this position data is stored in a form of compressed JSON blobs in a SQL database. Don't even need to tell you that there is absolutely no use of having those JSON blobs, compressed JSON blobs, in a relational database. And to just give you an idea, for one of our clients where their database was around 21 terabytes, this compressed gzipped JSON blobs were taking 19 terabytes of it. That's over 90%. Luckily, AWS has a solution for that, which is S3. Just put everything there, so serverless file system, it's a cheap storage, and even has better querying capabilities than the relational database has on this type of data. By removing all of that data from the relational database, we not only remove those bottlenecks on CPU when we are writing it at the burst of write, and noisy neighboring as this is a shared database, we also removed the problems that we had with backups. However, by distributing the compute, we introduced another problem. Now these results are being written from 200 containers at the same time. We are hammering this still shared relational database, eventually crashing the SQL cluster and causing a major incident. The first thing that we did was to slow down these writes, as getting more powerful SQL cluster was just too expensive. Luckily, we didn't need to stick with this workaround for too long, because Amazon released Aurora Serverless v2, a serverless relational database that is able to scale up very rapidly to allow these bursts of write from 300 containers very comfortably. And then when those bursts of writes are done, is able to scale down, which has also made it very cost-effective to split these storages into each client's AWS accounts. With this solution implemented, we removed the need of yet another set of large, self-hosted, long-lived Windows boxes and removed these bottlenecks on storage. Now, we talked a lot about, these components, patterns, but what is the only thing that really matters in our world? Does it work? Did it make any impact? And yeah, it did. I wouldn't be here standing in front of you and talking about this. We made significant impact for some of our more complex clients. Let me show you an email from one of our clients, the largest Canadian bank. Hi, today's XML file uploading process completed in 39 minutes. It usually takes around 1 hour and 40 minutes to complete. Could you please confirm this is due to the architecture upgrade and it was done last night and that there is no issues with today's processing? Thank you. Yeah, whew. We saved our clients 1 hour of their time a day, 1 hour that they can be spending delivering value to their clients, which could potentially be you. We enabled our business to develop new products. We are not afraid of getting any more clients, especially the bigger whales. So let's summarize. Our core service is more stable. We have predictable runtimes and fewer incidents. It's much faster for some of the more complex clients. You saw the email from the Canadian bank. It's also cheaper. Lower maintenance costs, fewer incidents, but also our AWS bill is lower. This is our bill from 2 years ago, from April, when we had all of that long-lived infrastructure self-hosted. Can you notice where the weekends are? Yeah, I can't either. We're paying always, even when our clients are not using the service. Now let's take a look at this. Well, the biggest difference is you can see where the weekend is, right? We are paying only for what we use. And our database storage, our database costs, gone down 70%, 7-0. But that's not all. We made the rule engine better for the environment. So for us, the urgency for this change came from the business risk. If we didn't make these changes, it would be very expensive to support any larger clients. And we were afraid that we would not be able to support them. But we also care about the environment and the world that we are leaving behind. So the best thing we can do, the best thing everyone can do, is to not run any software. That's something we sometimes need to do. Like say no to the requirements that don't bring value to your clients. Say no to requirements that don't bring any business value, that don't make your business better. However, the rule engine is an invaluable component to our clients. So we accepted it will cost some energy and it will cost some money. The important question is, what are we doing to reduce that negative impact on the environment? Other than to be able to scale up and support bigger workflows, one of our main goals was to reduce the cost and remain profitable. And in order to reduce the cost, we have eliminated the compute infrastructure waste by running the rule engine only when needed. We got rid of that over-provisioned, underutilized infrastructure that was running 24/7. That also reduced the electricity, which is often factored in to the cost of running a service. At these early stages of your journey to green, cost is a brilliant, simple metric to monitor your improvements and to see your reductions in carbon emissions. And you should absolutely use it. It also very much speaks to the rest of the business. In order to know what changes will bring the value and the most impact, we need to get the data. And this is to save our time, to not waste our time on silly changes that don't have any impact, right? And sometimes this data tells us we need to improve the performance, but not by adding more nodes and actually spending more energy, but by improving the performance, making the rule engine work smarter and not harder. For us, this often meant, and for you will as well, removing performance bottlenecks. For us, they surfaced after we were onboarding more and more complex clients, but also with inefficient data access as we are now running in a distributed world. Of course, there is a secret source as well, our culture, the people. We do care about this. Now, we are at serverless days, so I assume most of you are already on cloud. Okay, so I don't need to sell you cloud over prem, but I think it's very important for you to understand why cloud is helping us make it be greener. Cloud providers spend a lot of time optimizing their software and making the most out of the hardware. The more they optimize it, the more money they have, the more profit. But it also often means reduction in carbon emissions. Now, this doesn't mean that they care very much about the environment, but efficiency is coupled with green, and efficiency is coupled with cutting down the operational costs. This is an official definition of green software from Green Software Foundation. Green software is software that causes minimal emissions of carbon when it runs. What's more interesting is green software is cheaper. By using cloud-native solutions in the way that are intended to be used, we are taking advantage of providers' optimizations, and we are cutting down the costs. By using auto-scaling, we are preventing over-provisioning, which means we are paying for only what we use. Green software is also more performant. As we saw, efficiency is coupled with green, and efficiency is coupled with performance. One of the well-established ways to improve the performance is by choosing the right storage. Guess what? It also reduces carbon emissions because providers can be much smarter about the resource usage. Green software is resilient. Modern reliability comes from resilience, not redundancy. So instead of having those extra systems, just in case of need, just idling and wasting energy, let's be smarter about this. Self-healing, auto-scaling, it uses much fewer resources and makes green software. Green software is also secure. A greener approach to security is by being able to solve problems because they even impact us. So instead of going after DDoS attacks by providing more resources to be able to take the hit, let's detect a DDoS attack. Let's kill those zombie servers that are not doing anything, and they're just increasing the surface of your attacks. And you know what? It's not fine. Our planet is screwed. We are not the biggest culprit, but we are one of the culprits. And as techies, we are in a really good position to make a big change. And we are far beyond small steps. We need the big change. So let's measure what we can measure. And let's pick our battles. We still might not know what exactly works, but let's not get that paralyze us. We still need to figure it out together. Being green software is not just a hype. Those companies and those software solutions that don't adopt this approach, that don't adopt green, will stop to exist. So let's get better at this. And I'm going to leave you with one last note, the one that I want you to carry throughout the day as you listen to the other amazing talks about how cheaper and faster you can make your software. When you get all of these ideas and it starts popping in your head, every dollar you choose to spend is a vote for the future you want to live in. So choose it wisely. Thank you.